Hello, I'm Barbara Burlingame. I'm here to talk to you today about evidence and data. First, I'll tell you a bit about myself. I'm a nutrition scientist. I'm a professor at the Ritter Institute of Massey University. I'm specialty chief editor for Frontiers in Nutrition. I'm a member of the high-level panel of experts steering committee for the Committee on World Food Security, and I am a fellow of the International Union of Nutritional Sciences. I'm also former chief of nutrition at the Food and Agriculture Organization of the UN. I'm a former director of InFoods, the International Network of Food Data Systems, past editor-in-chief of the Journal of Food Composition and Analysis, and a few other things. In many food systems and nutrition policy processes, we talk about data-driven approaches and evidence-based policies. So it's important to define what we mean by this. The simple definition of being data-driven or evidence-based is being determined by or dependent on the collection and analysis of data for decision-making and policy development. So why are data and evidence-driven approaches important for sustainable food systems and food security and nutrition? Well, the 2022 report from the high-level panel of experts offers some key points that give the imperative of data, and not just for evidence-based policies, but also for projects, programs, and research directions. What is clear is that high-quality, timely, and relevant data are key to inform actions that promote better access to food and improve nutrition. Evidence-based mandates are everywhere. The World Health Organization has them, the Food and Agriculture Organization of the UN has them, and all the global policy instruments have evidence-based mandates. Evidence is the quantitative and qualitative information we need to base policies and decisions on. Typically, what comes to mind here is experimental, empirical evidence. Hierarchies of evidence are commonly used in these evidence-based mandates, and many of these strength of evidence models originate in clinical sciences, but are widely applied. In this conventional hierarchy of scientific evidence, used widely in judging and classifying the strength of evidence, you'll see that traditional knowledge comes at the bottom of the pyramid. In other words, it is classified as weak and is often excluded from policy processes. It's excluded from inclusion in critical and systematic reviews in the scientific literature. But considering that traditional knowledge is based on hundreds, if not thousands of years of observation and lived knowledge, a rethinking of this hierarchy is required, including for assessing data on sustainable food systems and diets. In my work on the high-level panel of experts, we produced a report for the Committee on World Food Security on agroecology and related agricultural processes. Several of the recommendations based on traditional knowledge were rejected by the committee. Why were they rejected? Because hierarchies of evidence were used to say, this is not real evidence, this is anecdotal, this does not fit with our empirical model of strength of evidence. But these hierarchies of evidence need to be re-examined so that traditional knowledge is not rejected from policy debates. In 2021, the White or WIFLA paper on Indigenous peoples' food systems represented a turning point in expanding the boundaries of scientific evidence. As clearly stated in this paper, traditional knowledge of Indigenous peoples needs to be recognized, respected, and valued with equal consideration and integration into these policy development frameworks. In addition to rethinking hierarchies of evidence, we must think about what data are needed. Fundamental data gaps exist. For example, we need a greater breadth and depth of data to monitor and achieve the Sustainable Development Goals. These 17 goals were adopted by the UN in 2015. They represent a universal call to action to end poverty, to protect the planet, and to ensure that by 2030, all people enjoy peace and prosperity. Hence, we call this the 2030 Agenda. All of these goals are fundamental for sustainable diets and sustainable food systems, but most directly and importantly is Goal 2, the No Hunger Goal. The full title of Goal 2 is to end hunger, achieve food security, and improve nutrition, and promote sustainable agriculture. To achieve the targets and monitor progress toward these goals, data are important, including data on food and nutrient composition. We need data on the nutrient composition of the vast biodiversity of foods consumed across the globe. We need data on what influences this composition. We need data on the consumption of these foods. And we need data on the many thousands of beneficial non-nutrients that have not been widely analyzed, and also on the harmful components. We need to know more about what people are eating in order to develop policies for food-based dietary guidelines, for example. And we need more data to characterize food systems and ecosystems. But it's important to note that a lot of data are already available. They're there. So the ability to access these data is another important area of focus. Existing data need to be appreciated, used, and built upon. Let me share a case study with you from the work in a small island developing state, the Federated States of Micronesia, from a research project and a series of books on traditional food systems of indigenous peoples. The story begins back in the 1960s and 70s, a time when there was widespread vitamin A deficiency in Micronesia, including xerophthalmia, which is the most significant cause of blindness in children due to vitamin A deficiency. This came to the attention of the World Health Organization and UNICEF. They went in with a remedy, vitamin A supplements. This did solve the problem, but it was a temporary remedy. And when they left, and the supplement strategy was not combined with a sustainable food-based approach to solving this problem of malnutrition, the problem was destined to return. Now, Micronesia is a biodiversity hotspot. Let's take one example, bananas. There are many different varieties and they come in many different shapes, colors, and sizes. Unfortunately, an impact of colonization has been a shift in recent decades away from the dietary diversity of these traditional foods towards a reliance on imported foods. So even though the people had local bananas, they weren't eating them. And instead, they had access to the big yellow banana, the Cavendish banana, that represents the majority of commercial banana production and exports from Central America. The native bananas were just growing wild in the jungle, falling to the ground, rotting, and not being consumed. These local bananas had been consumed in Micronesia, likely for millennia, and their consumption as traditional staple foods predated the emergence of vitamin A deficiency in Micronesia. When scientists analyzed these traditional bananas, they found that they contained, some varieties, as much as 8,500 micrograms of provitamin A carotenoids, which when converted into vitamin A equivalents, means that as little as 35 grams of a banana, a local banana, could allow the child to meet his or her vitamin A needs. Cavendish bananas have almost no provitamin A carotenoids. So now, through policy actions and widespread community adoption of a program called Go Local, these carotenoid-rich bananas are being domesticated again. This example illustrates the importance of combining traditional knowledge and empirical sciences and is providing a more sustainable approach to solving the problems of malnutrition. A deeper and more expansive understanding of the world's edible biodiversity is providing evidence, both traditional and empirical, that promoting biodiversity for food and nutrition can help to provide a more sustainable, long-term solutions to all the problems of malnutrition, compared with the purely clinical single nutrient approach that is in widespread use as supplements and fortificants. This evidence in the hands of communities and policymakers has the power to transform food systems and make agriculture more sustainable and more nutrition-driven. Leveraging agricultural biodiversity for sustainable diets requires the coordinated and collaborative efforts of the sectors of agriculture, health, environment, and education. Data across these sectors and disciplines are essential for addressing challenges of malnutrition, for strengthening food security, for promoting the sustainability of food systems, and it is the responsibility of scientists now and into the future to re-examine hierarchies of evidence, to address data gaps, to promote the utilization of data for the 2030 Agenda and beyond.